Hello everybody, my name's Corinne Andresen. I'm a sophomore in biomedical engineering and I do biothermodynamic research in the laboratory of Dr. Madeline Shea. Chronic pain is a problem for millions of Americans, and with the aging population, these numbers only seek to expand. Unfortunately, despite how far medicine has come as a discipline, the usual treatment for chronic pain includes the simple prescription of narcotic painkillers. Now, these pills, though strong, can have a myriad of potentially unpleasant side effects, and addiction remains a real possibility. If we want to develop a better treatment for pain, we need to, instead of treating the symptoms, we need to go deeper into the mechanism that causes pain, and this is my research content. Now, the molecular basis of pain depends on nerve cells, which carry the signal from, say, a cut on my finger to my brain. A key component of these nerve cells are proteins, tiny molecular machines that do all of the physical work in our cells. I am specifically concerned with this protein right here, a nerve cell protein called a sodium channel. A sodium channel works by pumping sodium ions into the cell, which facilitates electrochemical communication between muscle cells and our brains. That is to say, these channels are responsible for making sure we actually feel pain. Now, sodium channels, instead of just standing alone, are themselves regulated by calcium ions. And if the sodium channel is mutated in such a way that it is unable to bind calcium ions, it will not function correctly, the nerve cell will not function correctly, and the pain signals essentially shut down. You may be wondering why I have bothered to include this adorable little mouse and this happy-looking family on my slide. But these two, this knockout strain and this familial mutation, are proof that this mechanism actually works. Their sodium channels are mutated, calcium ions do not bind, they feel no pain. Obviously, this is kind of a lucrative condition for someone who does not feel pain, for someone who suffers from chronic pain. In my research, I use fluorescent biosensors and nuclear magnetic resonance imaging to essentially try to identify the three-dimensional structure of the sodium channel, make a molecular blueprint, if you will, of how it functions, and so we can identify those exact specific mutations that make people unable to feel pain. If we are going to go away from simply treating the symptoms and get to the core of the problem of chronic pain, we need a deep understanding of the molecular mechanism, and from there we can hopefully move to develop non-narcotic and safer chronic pain treatments. Thank you.